Welcome to China Manufacturing Decoded from Sofeast, the podcast where we take you through the major news and topics facing importers and manufacturers in China and Asia today.
Hello and welcome to another episode of China Manufacturing Decoded, our podcast that comes out once a week. And this week we're looking at a topic related to product design. A good product design does not fail, right? When it's used by users, when it's in the field, that's related much more to product design than actually product manufacturing, but a lot of people don't really understand that. And to discuss this topic, today I am with Andrew Amirnovin, who is the head of new product development at Sofeast. So we work together. And he and his team follow a number of new projects as we help some of our customers with development and we transfer to manufacturing. Okay. Hey, Andrew, how are you doing?
Good morning, Renaud. Good to be with you. Want to give you a quick intro to
Cool.
Our listeners. So basically, my name is Andrew Amirnovin. I'm from California, USA, and been in reliability engineering for over 20 years. My background is electrical engineering and MBA in technology and management. And also, I have been in ISO 9000, requirement and testing and implementation. So right now we're talking about reliability, and one of the biggest impact that I had in my career was developing a process for AT&T that's been going on for 14 years. It's called DIRT testing, device integrity and reliability testing. Some other companies basically took a version of that and they called it waterfall. And so good to be with you, and let's kick this in.
Yeah, so we have a real expert here on that topic of reliability, especially in the field of electronic products, electronic and electromechanical, let's say. And a lot of these same topics, these same ideas will apply to products that do not have electronic components, but we're going to focus on that because that's really a lot of Andrew's past experience. So the first thing I want to cover, because I really want to make it very, very clear, if I go, for example, on Amazon and I search for some products and there's some bad reviews, well, there's going to be some issues coming from quality problems and some issues coming from reliability problems, right? And people don't make the difference. But if you get, I don't know, you buy a Bluetooth speaker, cheap Bluetooth speaker on Amazon, you receive it, and the packaging is already half crushed, and like the colors don't match from the top and the bottom part, and the sound is horrible. That let's say that's probably quality issues. However, if it looks nice, it works fine, but then it stops working after 3 months, is that a quality problem? Well, if you've been listening to it nearly every day for 3 months, that's probably not a quality that comes from bad manufacturing. It's probably more coming from bad design, and that leads to an early failure. And trying to forecast, these early failures or earlier than desired failures is really what reliability is all about. Does that make sense, Andrew?
It does. You said it better than I would. I think that a lot of people don't really know the difference between product quality and product reliability. Product reliability basically means the whole product is not only high quality but also reliable. So the way I explain quality is that you have a design to in order to design and manufacture a product, and if it's done well and it meets all the design and manufacturing requirements, okay, then it's made, per quality requirements, and it's basically a quality product because it meets all the design and manufacturing requirements. However, if it looks good, but it doesn't last long enough to use it, or as you said, 3 months, 6 months, then we have a reliability issue, because reliability really means that you have a product that is designed well, made well, but it must last well too. And if it doesn't last long enough and to operate at least to the warranty limit, or at least to what the manufacturer is claiming to that period, then you have a serious reliability issue with that product.
Right, exactly. So if I buy a cheap Bluetooth speaker and there's no useful lifetime kind of promise, if it starts fading after 1 year, well, it was really cheap anyway.
Right.
Maybe I'll buy a new one. I'm not going to complain. I'm not going to feel I was cheated. However, if I buy a set of Bose headphones, I mean, these things last forever. I've had some for I forget how many years. That it stops working when you lose them, basically. They don't stop working when because of some kind of malfunction. But if I buy that and it stops working after 1 year, I'd be like, what happened here, right? So it really comes with the marketing claims and sort of the promise of the brand and things like that, and also the kind of product category, right? Again, a cheap Bluetooth speaker, I mean, nobody's going to die, but if it's a medical device, something implanted into the heart as a sensor to make sure everything's okay, or even worse, to keep you going, well, you absolutely have to keep it going, right? I mean, I think you did work on some medical devices that were doing that, right?
Yes, actually, I did work on a product that we called it the ventilator, basically due to COVID's rise. And when it comes to that, it's more like a life and death situation. That ventilator must work always on situation, and it must save life. So, failure is absolutely no option, especially when there's not enough of those ventilators. I agree totally.
Yeah, right. And so that's really a very, very important distinction. And when, let's say you purchase a product and then you talk to your manufacturer and you complain about issues, well, it's really, really important to know if these issues were right there out of the box. Like I open, and 10% of the time or 50% of the time, this accessory just fell off or something, versus or the product doesn't even turn on, like the battery is 0%. How come? And in that case, it's actually much easier to go back to understand why, because there was no user action, right? Oh, the battery fell to 0%. How come the BMS didn't stop that? Didn't force it to shut down? But to start with, how come they were so low on battery? And how, then you can do an investigation, but it's still, it's still easier to go from effect to cause and to try to understand, rather than, out of the box, they were okay, no problem. But then some people started to complain about that some weeks into use. And then, like 3 months after or 6 months after, there were a bunch of people who complained that it stopped working. Well, that is a reliability issue. And then it can be much trickier to do a failure analysis and to really link it back to where it comes from. Except, of course, in some cases, you look at it and you say, well, this component was underrated. Sometimes it's pretty obvious, right? But in some cases, it's very murky. Does that make sense? Or is this something you experience also?
No, I have, and you're on point. No trouble found, dead on arrival. These are very, very common and troublesome problems that pretty much happens daily for many, many manufacturers and and product designs. And a lot of times, really, it has to do with a combination of tasks that needs to be done in design and development and MPI phase. And all you need to do is miss one area and not properly test for reliability. So the whole point of the reliability testing is to catch the areas that basically are supposed to be a use case environment, and during the use case environment, unbelievable things can happen. The users use the product in so many ways different than what the designer even thought about. And the whole point of the reliability testing is to catch these issues and feed it back to design and development so that they can fix it, so that you don't see it in the real life scenario. Unfortunately, as you know, a lot of manufacturers and a lot of companies basically don't believe that you really need to do thorough reliability testing. And in fact, reliability team budget is always minimized. And because of that, you end up doing a fast and quick, not a customized reliability testing. And then a lot of the reliability engineers hired in that type of environment, they pretty much go with the old traditional, well, I'm just going to use this MIL spec, or I'm going to use this EIA spec, which were designed, honestly, like years ago. They don't even, half of them don't even apply for today's technology. And so to blindfoldly just apply a standard and not customize it to your own product use case, you're looking for trouble. That's exactly what's happening most of the time.
Right. That's a great point. Maybe we need to take a step back so people really understand. If we try to simplify a little bit, to confirm reliability, as you said, you need to go for testing based on the expected, foreseeable use by expected users and things like that, and within their environment and so on. You really need to understand all that. So let's say I develop a new product and I'm just starting on the design, and I'm starting to make some prototypes. At this point, is it too early to think about that? Or are there already some, or does it make sense to do some testing to confirm that this design, is not likely to have reliability issues?
I really think that when it comes to reliability, you have to reliability and quality. They must go hand in hand, right? At the moment when the designer is about to sketch the initial design. Because if he doesn't understand exactly how this product is going to be used, then he is not going to design it properly for reliability. And if he doesn't design for reliability, design for quality, design for manufacturing, which, what we call it is the effects, then you're looking for problems. So I definitely agree with you. So it has to go hand in hand right at the initial design.
Okay. So initial design, at least in the planning,
Exactly.
gathering the requirements from customers and typical users that are targeted, safety regulations and things like that, and how
at least the minimum.
Yeah, at least the minimum, right. Try to collect all of that and make sure, put it in a clear brief so that at least the designers, the people working on also on the engineering are aware of the broader context. I think that's what you mean. And then when you get to prototypes, very often I see that we help our customers actually test the prototypes to failure. So can you explain a little bit, what do we gain from that? Why do that? What do we learn? What is the output?
So in design and development phase, test a failure, especially on the component side of things, or even the product itself, is very, very important to understand the limits of the product with respect to, for example, voltage, high voltage, low voltage, high current, low current, high temperature, low temperature. and some other environmental thing. You must do your design. You must understand your design limitations, and test of failure is a great way to understand. For example, I will tell you one case that I actually was involved with a fan in a very, let's say, one of these projects that was a big rack mount project and required a fan to cool the internal temperature. And so there was two fans, one intake and the other one pushed heat out. And in this particular case, the designer basically was aware of what the operational temperature was, and he went ahead and put in a fan that, for example, went from 0 to 50 degrees. And he thought that, that would be just perfect. That would be enough. The problem was the temperature internally actually went over 60 because of the fact that it was also inside the room, and the room was also warm. So these additional temperatures increased the operational temperature to up to 65 degrees. And so we had all kinds of fans returning. And then what we found out was that this fan in particular was never, ever tested in the design to see what the limitation or limit of the product is. In fact, that particular fan pretty much failed at 56 degrees, and it was spec'd for 55.
Wow. That's at least the manufacturer of the fan knew what they were doing, right?
Yeah, exactly.
Yeah, but so then the full product went into production, was delivered, and then the fans did not do it,
So pretty much every single product was returned for changing the fan. So the hassle that everybody has to go through post-production because of one stupid mistake, oh my God, it's just amazing. So it is very critical for design and development team to really do and understand not only what the component spec and data sheet says, but also confirm and verify that under their own product use case, how is that product going? How is that component, for example, going to function and operate?
Now, so let's say prototypes tested, then designers learn something, make a new prototype that integrate the learnings plus maybe some other improvements. Then this type of reliability testing might come back several times, right? Until it's really confirmed, the performance and the reliability of the final prototype is all good. Plus, user testing also says it's good, so we can freeze the product design. Is that correct?
Well, you said something that is extremely important that many, many companies, and in fact, a lot of reliability engineers, particularly the junior level reliability engineers, don't understand. And that is right at the beginning of the design, you have to have a very, very good and proper reliability test plan. And that test plan right at the beginning must have confirmation of testing for some of the components on the engineering level. So it's a little bit more than just a product level, but it's also component level, PCB level, and then product level tests. So the initial test is extremely critical to be thoughtfully designed so that I'm talking about the test plan. The test plan has to be thoughtfully designed so that it really covers all unforeseen scenarios of use case environment, either in the field or even during the testing. And so you want to make sure that you catch all these issues. And then as you go from one build to the next build, you must not change your test plan. This is the biggest mistakes happen all the time. All of a sudden they loosen the spec and the next test, or they tighten it. Either way, you have just messed up the whole thing, because the whole idea is that, okay, you have come up with an idea of solid plan, and you just, unless there is a serious problem with the plan and you miss something important, yes, of course, you have to modify and update it. But otherwise, if everyone has agreed and it's been thought well, then you just follow it through all the way. And then that's, keeping the test plan constant, you will see that the only thing that is changing or the variable is basically the results. Your reliability growth plan is improving reliability as you go from one build to another. However, if you come up like at the last minute and you start thinking, 2 builds, we haven't been able to pass this one part, let's just loosen it and just say known issue and go. Well, you're looking some huge issues in the field soon.
Right. And that happens often when you have extreme pressure, right? So
exactly.
Just to go in a slightly different direction, but we'll get back to these different testings at different stages of development and production. That reminds me of the Samsung Note disaster, because there's no other way to call it. And when one understands the context of the launch of that phone, it becomes much more apparent that what you just said might have applied there. I mean, Samsung at that time was seen as a fast follower of Apple, but they were not seen as an innovator really in that space, at least. And they were not happy with that. So what they did is they switched. There was no Galaxy Note 6. They went straight to 7 to put it in front of the iPhone 7. Right. And I think they even wanted to launch it like 10 days before the iPhone.
Yes. Right.
and there was just enormous pressure, and they tried to cram every feature they could into that phone. Right. And they made it really, really complicated. And they released it. Well, if you ask me, I think what you just said is a mistake that some Samsung engineers made.
I agree. Yeah, let me explain. I agree exactly what you said, and you're absolutely right. The pressure that they put in. So let me give you our audience a little bit of background on that. So Galaxy Note issue happened between 2016 to 2018. Roughly about 2 million Galaxy Note 7 batteries were exploding spontaneously with no cause or no reason. Slight bend or little movements all of a sudden would spark a fire and explosion. It got to a point that even, nobody was allowed to take their phone into an airplane. So really caused mayhem in the industry. Cost Samsung $5.3 billion. And a huge number of customers basically went away from Samsung to iPhone, and never at the time actually I was working for LG, and we got really nervous because we were wondering what was their cause, could it happen to ours? We didn't have any issues because we were also making our own batteries, and then what really the root cause was found for Samsung issue was basically the battery itself was defective. And it goes back to what you just said, Renaud. Because of the marketing schedule, trying to beat the competitor, trying to be in the market first, they pushed their suppliers to the limit, to a point where the suppliers basically cut corners on quality and reliability, and they didn't really do thorough testing on this battery. If they had just done some of the very critical battery tests, bending tests, nail tests, and some other very critical drop tests, for example, they would have found these issues very easily. In fact, LG had never had this kind of problem.
Yeah, from what I understood, it's not just the battery. It's like the battery as it works together with the the components, the way they are set, and how all kinds of things is and they were working with, I think, 2 different battery suppliers,
Yes.
And it actually, there were some issues with both of them, even though at the start they thought it was only one of them. So it might not be purely, only one supplier skipping tests, but it might be also that you push the suppliers to make the battery so thin with so little protection, and that's a design issue. And then that goes straight back to reliability, right? Designing for reliability. Yeah.
Yeah, it really does. And, when a company loses 5.3 billion, it's very lucky for them that it was Samsung. They could afford to handle 5.3 billion. Any other company would have been basically out of business for sure. And Samsung is back. And of course, they have definitely shown that they have improved and increased their reliability on all levels. And it was a huge eye-opening thing for Samsung. They almost went out of business, basically. And so I think that this should be a lesson to just about every company who's making any kind of product, that if you don't put in small amount of money that looks big at the beginning of the development, then you're looking at possibly losing huge amount of money, or even losing the whole company over reliability testing cost.
Well, and killing people in the process, depending on the kind of product.
Oh yeah, that's another one, right? So, for example, the airplane crashes, the Max. What was
737?
Yes, that was an amazing issue with an airplane that killed over 300 people until they found out it was just a software issue.
Yep, software and lack of training and so on and so forth. Yeah, with no controls over that issue. And that again was, of course, when they introduced that, when they developed that software, they did not think, well, what's the pilot going to do?
Right.
Oh, maybe they need special training.
So, I could translate that like a very thorough, detailed user manual. Have you ever opened the user manual and you're like, oh, it's just 2 pages. But then you start using the product, you realize, oh my God, there's a lot more that I need to know, and it's not here. And so a lot of the pilots probably thought that, the other stuff is all automated. It's all not necessary to know about it. And there it is, caused a big problem.
Right. So, yes, just to go back to one topic, and then we're running out of time, but we can do a follow-up on the other types of tests later in production. When you say it is very important to have a very well thought out test plan. So the test plan, when it comes to reliability, and usually it's like you test for performance, you test for durability, reliability. I mean, it's you can catch a lot of issues with that kind of testing, right? It is really a translation of what's going to happen to that product once it's out there in the field, and is it going to withstand that, or is it going to go to fail, or even worse, to lead to catastrophic failures like the Samsung Note, overheating and then exploding. Is that correct? Would you say that it's really a translation of what will happen, and it allows the company to learn how well the prototypes are doing, and then later on really to confirm that production is okay and will not lead to failures?
Yeah, that's a great point. So a lot of companies totally forget that there is somehow they need to validate and verify that the production units coming out of the line are actually still meeting the quality and reliability requirements set forth right at the beginning of the design. And unfortunately, it does cost money because you have to take some samples from the line and actually do reliability testing, and those samples are basically destroyed, costs money, and you can't do it only one time, and you have to do it continuously. That's called ongoing reliability testing. And if you don't have an ongoing reliability testing, which mimics pretty much the original reliability test plan that was created, except more of a critical test that will catch like 80% of the issues. And then once you catch it, then you must do the full reliability test to see actually what really changed and what's the deviation compared to the original plan. And unfortunately, again, all of these things cost money and time. In some cases, the failure is so big and huge that the production must be shut down. And most companies can't afford shutting down production. It costs money and revenue. And so, there is that trade-off that they have to think about. Do you want to put ongoing reliability test plan in place, or you want to risk having some issues down the line in 6 months? The great thing about ongoing reliability is that as soon as you start the production, the high volume production, and this process will catch in the first 30 days all the issues that are happening in production. Once you fix them, hopefully within the 60 days, there's not much any more reliability issues. And if production is consistent, then you should really not see any issues. However, if you don't have this implant, you will never know it. And then next thing you know, you have all kinds of field returns. And you and I see that every day coming from our customers.
Well, yeah, as you say, if you do that at the start of production, you can definitely find some issues. If they are there, it's highly likely you catch them, and then reliability grows, as you say. The risk goes down over time if you address the root causes of these issues. But then it really, in the longer run, it comes down to, hey, has the battery supplier changed something? Has the PCBA supplier, for some reason, done a redesign without telling us? Or whatever, right? It can come from different parties, and these are the risks of having an extended supply chain with a number of different critical components coming from here and there. I mean, it's just part of the risk, and then because there are risks, you need to have a budget for controlling, for testing if these risks are there or not. That's just the way it is. If you go for a very simple product that is never going to kill or hurt somebody, then it's a different different issue, right? So cool. I think we covered a lot of ground. That was quite useful. Thanks a lot, Andrew. And I guess we'll hear from you again soon here, because there's so many topics I want to cover around reliability, product reliability.
I totally agree. There's a lot to cover, and I totally appreciate you inviting me. Thank you very much, Renaud.
Thanks a lot, Andrew. And thanks to all the listeners, and we'll be here as usual next week. Thank you.
Thanks again for listening to this podcast, brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share, because it will really help others discover us too.